And thank you for coming to listening to me. And the idea I was talking, what I'm going to talk about is the trends and challenges in power electronics and control. And I have been to different places. I became a professor emeritus from University of West Florida. From 2017, I joined that university. 2017, I joined it here. Okay. And but this is my position now. Okay. But I'm glad to see that I have been elected because I've been into one of those people into the scientists. Okay. And I also, as it was mentioned, that now I also give a lecture on engineering education, and that's what I want to let you know. I like to be teacher. I'm first as a teacher. Now I would like to thank this your institute. I have been to I think 2 times at least, and I also thank to Professor Nimrod for inviting me, all of you for giving me the chance to talk to you. And the one I plan to talk about challenges in power electronics and converter. The first, I want to go back to you for many, many years before. It's not far away. It's about 130 years, 130 years. You can say that about 100 years. But you can see that there was the start. Electrical engineering started with the galvanometer. There was the first patent was. Then after that, they tried to use it. Look at that. It was like in 1984. After about 20 years later, there was an application used as an oscillator was used after 3 years when the idea came here to do that. Now after that, that was like another 20 years. You can see there was a radio communication of the tube was an tube was made a tube by one of the commercial company, the Muller was a British company, Muller. 1923, I was not born there, but then after that, there was some how to use it. There was a book about how to use that, the tube to make it oscillate. Now here, but somebody wants to, I don't have the date for that, but if somebody wants to use that tube, battery charger, there was a battery charger. This is the same one we do today. There was a transformer, there was a tube, there is a tube there. The same one, we replace it by a diode. That's the same configuration we use to have a battery charger. So here, if you look to that, people was trying to look into the same concept of the tube to controlling motor control. The two-phase motor control was trying to do that. Now here, that the electronics started, you can see that 1884, about 60, 70 years later, then 1947, that came, this transistor was invented by, at the Bell Lab, by, that is the beginning of our, whatever this revolution we see now in different places. Now here after 3 years, 2 years or 2 to 3 years, there was about TV there, and then also field effect transistor. So you see that now we are talking now having a transistor. It's about starting 1950, about 70 years from now was that. Now within the 70 years, people are looking for how we can people are looking for how we can control the power flow. During the Second World War, people are looking for how to control the power flow. Then the diode was like a diode, you cannot control it. But that's why now again in the Bell Lab, they came up with the idea of that Bell Lab was coming into how to control that the diode. That's come this the transistor, then they come to this silicon control rectifier that becomes a thyristor. That is the time becomes the power electronics being, you can say, born or started. That is about 1960. Then if you're looking for 60, then 40 years plus 20 years, you're talking of this, the age of power electronics, you're talking about 60 years. Now here, During this time, people are looking for that 1950, another after you can see that about 10 years later, that concept became a commercial that thyristors came up by this, or developed by General Electric Schenectady 1960. Then if you look through there, that you're looking for 60, 40, 60 years, as I mentioned too. That is this finding that beginning of, as I say, the birth of a power electronics for processing and applications of power or power conditioning. Then that time people are looking for how to get used to the power in the application or teaching that. There are not many books. 1964, after a few years, then came a rectifier circuit by Schaeffer, how to have a rectifier work using those, diodes. That was the book if you'd be looking for or students or researchers. Now here, then this actually, they started in 1971, and when I did my work as a master student, I worked on the of non-destructive test of the thyristor. What are the characteristics of the thyristor? Just to know them. That was like, 1970s. Then you can say 30 plus, we are talking of 50 years now that thyristor came here. But here, then I work on the project, to be honest, into a project. It's like a 1 kilowatt, 240 volts from a 24 and 12 volts and 24 volts and that to have a inverter then. But I work on during the time I work on PhD thesis on that regenerative rheostic braking. That was a new thing happening then. That's the things coming up. But if I look to the system now at that time there was the state of the art. If I look through now, this is old stuff. This is nothing. Okay? Now here the people are looking for understanding what was a thyristor silicon conductor rectifier. The Westinghouse started to have Westinghouse started to design a guide, and then General Electric give you some guidelines about what are those here, what are the silicon conductor, what are the characteristics, how we can, and then they're giving us an handbook how to use that. Now here, if you look through this, I look through, I don't know when is the date, I look through this IEEE Explore. Now today, it's about 30, 50 years. I look through that. I searched by the word, power electronics search by the word. But you can see that it found about 271,000. And then conference, 197 conference, the journal. And then look at the books. You see, why it is going, it is impossible for anyone to read all the articles and all the conference, what is happening. The journal. Okay? That's what happened. Not only that, we got a magazine, courses, a lot of early access articles. That's what we are today. I don't know what will happen in another 50 years. Unbelievable. But now the question is, now another things we are coming into now, as of now, there are a lot of things we hear about electric vehicles, electric vehicles, the way we have been doing, like, I want to give an example. We have been doing for over the years, we have been using gas engine, there is a pollution, the gas will be run away, the petrol will be run away, we need to go for other things there. But if you are in a Mexico City, if you are in the main road, if you walk, then you can realize how much pollution we are getting from. This car is going to pollute us. And that's what happened, because we are the human being, we have to breathe, and the air is polluted. Now it looks many government, many people are looking into going into electric vehicles. That's not going to happen in a one day. If you change all the gas station, you have to replace by charging station. We got all the cars, we got a long way to go. But what I want to emphasize for you, if you want to go there are many issues. From here, that onboard energy storage, we are looking for power electronics converter. You have to have some transmission connection there, and then how we charge them. The charging issue is it we have to sit down in our car or put the car in a garage or how you charge this battery. There are many ways to do that. I could have a battery, replace it. Like, I could have my battery here or there. I go to the garage, somebody can replace the battery to put another one. That's possible. There are many ways. What I'm going to tell that there are a lot of issues come here. The issues come here. Then we are replacing the tank. Something tank, how you pick it up. There will be how you do that. There are a lot of things come here. Because if you're looking for a power converter, it's not only a converter. It needs the capacitors. You got devices. You got an inductor. You got many things. Now here, where do you put them? How you keep them there? What is the weight? What is the size? Where do you keep them there? Many things come here. Okay? And then I just give an example. I have a handbook, which is called this, and there's called the How Do You Learn This Charging. And there is a chapter on that. We're trying to revise this one, chapter 34. This is the article. Now here, but there are, if you're looking for the one part of this one, the other part of looking for is to connect into renewable energy. We are looking into, we need to replace the traditional, the gas, like a oil-fired or the coal to the electric or the renewable energy. If we do that, whatever we do, it has to come from that. We have to come, wherever they go, you have this one, we have to come from a transformer. We have to get for the filter, we got the rectifier, we got an AC to DC converter. Then we have to go back to our turbine. If you got a turbine, generator, wind power, whatever I said, we have to go back there. There are many things inside because we have to have a lot of control. We have to have a lot of control. It's a system basically, and that's give you an example for a tidal current system. Like if you get a tide here, they have to be tide has to be converted into electricity. That it's a tide is a big one. If you are near like the Veracruz, if you are near a Mexican, or if you know this south of the Mexico or near the sea, you stand up to see how much the wave is coming there. The tide is coming there. If we can get this energy, that is also a way to have that. There are some projects, the tidal energy converted into that. It's a big project in Scotland. It's a big one. It's Scotland, UK. Now here, but there are many ways the things will change. We don't know what is going to happen. Depends on how the technology goes. Maybe I have a car, I sit down there and then sit down. My car will charge. Charge this one. There will be some charging. Maybe charging station will come there. Maybe you're driving, the road will change. Maybe when I'm driving, as I drive, there will be charging. You don't know how it's going to happen. What I'm trying to say that there are different sources. You can have wind, you can have solar, you got power or different times. We are not going to change those power stations right away, okay? It's going to take a heat, take a time there. That means there are possibility of coming here. Power electronics will be playing a role in every place. That once you got the bus bar, there's some people who will need this for a refrigerator, somebody for TV, somebody for light, somebody for autonomous and robots. Different people will need different things there. But whatever we need that, you can see that power electronics, as long as you need the electricity, the power electronics is there. The other question come here, would it be AC transmission or DC transmission? Because when that electricity was generated, the issue was DC transmission or AC transmission. That coming up, the idea of the Edison, and then in Edison and Tesla, the issue come here, the AC or DC transmission. But now with the power electronics happening there, power electronics being there, we can convert, we can convert to DC to AC, AC to EC, any more conversion we can do. All these things was done by, what you call a transformer. It could be done by those power electronics. Where it is going to go, we need to see where the young people, like many of them, where they take us. But here, there are other issues come here. If you are looking for, just to tell you, I'm not solving any problem. I'm just telling the issues come here. There will be like a power station you have. There is a distribution you have there. That could be distribution. Then there will be sources of renewable energy. There will be different way you can come there. There will be transmission center. There will be distribution center. There will be energy storage somewhere. You cannot send all of them. There will be access there. There will be some renewable, other type of solar there. There will be substation, different places there. But they have to be communicate. Once they come here, they will give a commercial supply. There will be distribution. There will be industrial plant. A lot of things will go at communication there. But here, these will be done not the actual power by the electronics way the communication. Power will be controlled by like electronic type of the control or communication way protocol. I would say communication protocol. There will be back and forth there, but that is a question of cyber physical system. How do you protect it there? Like if I go to the bank now, we are all scared of. If I go to the online through my bank account, I'm scared of who is going to see my, what password I'm typing, what I'm typing, these are things. There are also threats to the infrastructure itself. There are protocols attack. It could be in routing attacks. It could be in different types of attacks. Could be intruder. Could be looking for different structure. We need to look into these issues too. It's also very important to look into those different structure. Threat is coming from every places. Like think about it, that if you got a water supply in Mexico City, somewhere is a purifying it. There is a water. We cannot drink the water as it is. There is the water plant we got that is coming from some water processing there. Somebody can go into that the system and manipulate them. This happened nearby, one of the city here. Somebody went there when they're doing the injection of chemicals. It was increasing very high amount. Then the operator realized it could be dangerous. These good people can do that. But here we heard about smart city. We are promoting a smart system. We are looking for. There will be small housing here. There will be apartment complex here. They will have a car. There will be gas electric charging there. There may be different types of things. They're going to have a solar. They have a microgrid only for that area, but not all of them they can have sufficient. There may be main line too. You see that this is a smart system you got here, but there will be some here. You don't know what people are doing. Somebody may be taking the cryptocurrency, taking a money dollar amount. They're taking a dollar. Somebody making a phone call. All are interrelated there. You see that these are the issues come here. A lot of issues come there. It's not only engineering for power electronics, but power electronics being a part of that, being a part of the system. We need to look into protect that power electronics and systems and all of them together. This is a new world we are looking into that. The power electronics is only one of the PB. There will be some converters there, but the rest of the stuff is also that. Power electronics maybe in the building. This just to let you know. Okay. But the world is becoming very complex now. The complex now, I'm sitting down into the operator is sitting down here. It is going to different places, going to the computer, going there. Then, different computers, different telecommunications, how they communicate. They communicate into this wireless, internet, and the communication protocol. Then, different places, the whole world there. When I'm talking now, doesn't mean I'm talking to Mexico. The signals could be anywhere in the world. Anybody could get into that. That's the things you're looking for. Cyber security is important. And not the security of the computers. We are talking of the security of the physical structure, physical system. We hear about cyber security, about the computers and cell phone and others. But I'm talking of cyber physical. Or you are an electric train. You are going from Mexico City to another place, like going to the Mexico City to another place. There, somebody and maybe take this train as a hostess. There, we are looking for your physical structure, your building, your power station, your water plant. You're looking train, physical system. Now here. I was a department chair here. Once I come to the West Florida department chair, I started a new program. It's called the Cyber Security Engineering program. Cyber Security Engineering, not a computer science. engineering program, which is started this year as a 4 years degree program. You are welcome to see the curriculum, which is called the cyber, what you call the cyber security engineering program. It's basically we have a one track or this, track on this, what is smart grid security, smart grid security, one part of that. The other part will be like a concentration, the common courses. The other one is the industrial plant security. The third one is the hardware security, how to secure the hardware itself, because everything has an embedded system up here to that. This is a new area is coming up that has a lot of potential, in the future. Future we have to think to it. Like here, if you're driving a car, think about it. We can think about it, car. If you're looking at type of car, a lot of cars are coming there, and they're going a hear about self-driving car, different cars are coming on the street. And you have to make sure there are no people there. It's a self-driving car. How you have to make sure one is crossing to the other one, another is not crossing to the other one. And this is a big mess. Can you imagine that? It's like giving your child, 10 years child or 12 years child, driving this road with your car, okay? Driving a car, driving this, different cars, different things. Yeah. That depends on how intelligent the system is. Okay? If you got a 10 years, 12 years child, give a car, and then they will be driving. All the children replace all these adults by the children. They're driving all the cars. Think about what will happen. It's a child, the brain is not developed. The brain is not developed because once you get an adult as a human being, our brain developed. As a child is a person like you and me, but their brain isn't developed. You are asking them to drive a car. That means the main thing is our brain development. If you are giving a self-driving car, you're looking for the technical computer brain you have injected that computer brain decide what to do. Yeah, with this one, there are a lot of issues come there. Issues come there, how robust the system is, how resilient the attack, and operating system, embedded components. Now, if you're an electric car, now what is the place to keep them? Inductor, capacitor, devices? Where do you keep them? How do you keep them there? A lot of issues called the electromagnetic field there, because there will be something that I'm sitting on the top of that. I may be subjected to electromagnetic field. One of the issues for power electronics, EMI, or electromagnetic compatibility, is the issue there. Like my computer has some power supply, there's some electromagnetic field it has. My cell phone you got have this one. If you look to the cell phone, take your cell phone and then put simple, it's called the what do you call the canvas, okay? What do you call which give you this, direction of the north south, compass, okay, compass. You just have your cell phone, took an ordinary compass, put it near this one. You're going to see that it's going to go to the cell phone. You're going to see that the indicator is field there. I check the quality of this one. I will put the cell phone into that compass and see whether it's a move there. If there is a move, there is something there. You have to be lightweight and energy efficient. There has to be remotely operated. You have to protect the system, and there has to be power will be coming from different sources. All has to be one of them. There are a lot of issues come there. It's not only the technical issue, it's the manufacturer issue, economical issue. Once you have that, where did it go? There's a lot of wind generation. You have some wind near the sea, that is good. But if there is a hurricane on Mexico, we see the hurricane. Now we got a hurricane, we got a cyclone, hurricane come there. If those one is a very strong one, 200 miles, they will pick them up and then blow up. It could be like a missile. Okay, it's a missile hitting those people, hitting those buildings. You don't know. A lot of issues. Now, what will be the power of in 30 years? I don't know, to be honest. I don't know, because that depends on where these engineers and scientists and technology take it down. But what I can say simply, I can say that 100 amp say MOSFET. You got 100 amp MOSFET, you have then 1 kilovolts. Okay, you got 1 kilovolts MOSFET, 100 amp. that will transfer from your source to your load is about 100 times, 1 kilovolt. Okay, you're going to take about zero point 0.1 megavolt amp to transfer them. But think about it. If this MOSFET made of silicon carbide, the silicon carbide is about 10 times more what you call the field, the density field. That means it can go to 10 kilo. If you got a 10 kilowatt MOSFET, that MOSFET you can drive easily. Now with a voltage control device, it doesn't take much energy to drive it. You can see that 100 amps times 1,000, 1,000 kilovolts. That is a tremendous to have a processing. That where the powerlessness will go will depends on how this technology develops, how our semiconductor device will develop. Is it a semiconductor? Is it a silicon carbide? Or is it a diamond? If there is a diamond, it's a much, much more than the voltage. About 2 years before somebody asked me what it is, I came up with an idea from my experience. The powerlessness is almost like a double. I've been going to the conference every year, number of papers, articles becoming double. That's why I say if it is double every 2 years, then if I say 2028, doubling is like in 5 years. If there's double in 5 years, and then it becomes a huge base, double in 5 years. If I do that in 2028, another few years, there will be about 64 times starting from that 1998. Somebody asked that question, 1998. Okay? Now, if I do this one like 1948, you're going to have a lot of them again. Where is it going to get? You can see that you're going to million times starting from that within 100 years. 100 years from 1998, 2000, 2098, okay, 2098, probably about a 1 million times will be going for that. That's this, is the way it is going up. Okay. Now here, with this one, things are changing. As I told you, I write a book and I work with Renewable on control system. Then the book I'm doing on that. So, if you are, I'm also editor for books for Springer. Somebody mentioned that. I'm trying to have ask people to share the knowledge. One is called the Springer Electric Cities. I have also Springer on that, energy proceeding. I have also CRC Press. I also special security engineering cities. If any of you interested to writing books for that, you're welcome to do that. That's the book I mentioned to you, my power electronics. I like to include design. That's what you call that. You see that I use a lot of spice or other one. And then, that's something, come to me. I asked people in Mexico in one place there. The question was coming up there, with those days, we can have a simulation spice or LT spice or any other type there. We can design things. We can see how it work or not into workbench, computer workbench. Then we can predict how this will work. We can change the parameters. We can see different things there. Now the question is how important that we go to the lab and build it. Go to the lab and build it. The building a lab is expensive. That was the responsibility. Building a lab is expensive, and then we have to buy the lab equipment. University doesn't have money all the time. But we can, if students do only simulation, if they can do practical experiment also is good. But if they do simulation, if it is a 90% accurate, 90% accurate, 10% not, but still it's a good. But the other question comes: how many engineers really, when they leave this university, they will be actually working on that lab, oscilloscope, multimeter involvement? These are the issue. Think about it. Also there are some small little small boxes. You can have those. You can have acting like oscilloscope, like a box. You can have test. This is the one I do that. This is the one power electronics I use that. This is the one new one I work. Couple of years I published in India. You see, a lot of the basic concept come here. Can you do this? Most of the experiments using that, LT spice or P spice, and I show that yes, a lot of experiments we can do design, using those software tools. It's a beginning step. If you can do practical experimental, fine. If not, we can do a lot of the things we can do that. If you're not sure of that, I would advise you to do this called this. Another one I do is called the LT Spice. LT Spice, I recommend now. LT Spice is a good one because it's free. The full version is a free. That one I recommend now. And my students. I've been working on this simulation for the circuit for many years. That book was started in 1996. I started with this, using the software tools. This many of you have seen that. I have books, you got. I think there is some Portuguese and some different area. If you are in a Facebook, if you're a student, you can download that lot of the files from that Facebook. You see, that's the one. If you remember, I thought I'd share with you. This is Chile, right? Chile, right? This is your institute. I was there now. I was here. I was in India. That's the one. The 2019 before the pandemic come. There was so much, but that was the last trip I have there. That was the same one we go for with this one. And then I would like to thank you to all of you to listening to me. If you have any questions, I will be glad to answer any questions you may have. One is called fundamentals knowledge. The other one is the actual interface. Interface like a hardware type, like a power electronics, a hardware type. Like if you're looking for controlling it, hardware type. If you use it, you can use it in robotics. You can use many other places. But how do you implement? It depends on artificial intelligence. You may have the different way, but these may be changing. The programming you do, they may change that. But what we need something which give you a fundamental knowledge so that we can understand them, so that we can adjust them, we can cope up with the changes. If you're looking for many years before, somebody will be doing some programming, like in one language, they are changing. Like you're looking for web page design today, you don't know what will happen in web page design many years before. You don't know. Yeah? Now, if you know what is the fundamental, what involves in designing it, the theory behind, what is the idea behind, what is the fundamental behind, that is the one is the more useful. food into the freezer, put it into the cool there may be something I can use them. Solar is there, electric line may not be there. You see, each situation depends on, but to have an electric car completely, it will be why. Okay. Now the question comes, shall we change the roof with a padded with this, solar, so that it can also have a solar and also the from the battery too. And these are the infrastructure questions. But is it doable? Yeah, it's doable. Whether it is economical, what is it feasible, when is going to happen, it depends on the situation we have. But we know that we have in my university, there is a research group, they're working on running an electric, what you call a small car, like a golf cart, by running from solar panel. They're working on not going a far distance, but within the campus, they are working on that. Yes, is it doable? Is it doable? How long you want to do? How much distance? That's the question. Yeah, it's doable.
Okay, thank you very much, Dr. Rashid. Claudia, here Jesus Mina from Cenided, we noticed that you lost your communication, and then I took the opportunity to ask a question to Dr. Rashid. Sorry for that.
Okay. Okay, this is technology. This is what happens. It's always the case, right? It's happening. There is a good question. There is no bad question. All are good questions. The pattern, by definition of the pattern, if you have an idea, somebody will say, if you got an idea, just put this idea into piece of paper. May not be, you're patenting your idea. Yeah, you patenting your idea, just patent the idea, and then after that, after a few years later, somebody may use this patent. It could be different area. I don't know. I cannot tell you. Couple of years before, I went to a place in what do you call the Metropolitan University in what is that? Veracruz. I don't know which city. Metropolitan University is a technical college. Technical college. I don't remember exact name. Technical college. They take those, from like this, like you bring those can, you got this, like the drinking can and different things there. They make those processing. The processing. There is an office. There is an office in Mexico City. I don't know the Metropolitan University. They patent them. There's an office to help them to patenting them their ideas. The patent is it could be anything. Patent could be ideas you have, like you are talking, I am talking, how to avoid breakdown. This could, if you have an idea, it's an idea. You're patenting an idea. Could be programming, it could be writing, you could be writing. There's a patent. There's a patent. It could be anything. Not a trademark. There's one is a trademark. There's a trademark, and there's a different one. Okay, we as a human being, there are two characteristics. One characteristic We want to see how it is helpful for me to learn, to be useful for the people, for the society. That's very important because everybody wants to see that they make things good for other people. That's the way. Like they want to help others. This is the number one. Number two, they want to see whether how it will benefit them, how will it interest them. These are the two things they look for. Now, if they think that that is in electronics, we need to, if you tell them go and study electronics, okay, they will not do that. If we show them some project, if you show them some project, this is the way you do, this is the project, this is useful, this is going to help people, it's going to help you, it's going to help the society. This is the way they will understand the benefit of that. And for example, a lot of people are going to mechatronics because they see that physically they're helping replacing that, right? They're going for robots, it's helping them. Okay? They're helping them, they're helping things that this is the way it's a benefit. A lot of people they go for medical field, okay, this physical field, then they can see they help the other people. Then they can see the people are crying, they are smiling, they can make a change there. This is people they want to make a change in the world. We came here, we all go. That's the truth. There is no fact about that. We all came here, all we go. Everybody wants to see a change with somebody else. They can help something. And if you, as I said, if you tell them, come on to my class electronic, they're not to come. We need to have them at the beginning, tell them how useful, have some projects, some hands-on, how to make that, make some, the IC board, make some integrated circuit, some board or something to benefit at the beginning. You see the simple question I can tell you. You can see that it's a little child like 2 years or 3 years. If you tell the child, help me that give some medical stethoscope or some blood pressure or something like a plastic or toy, you ask the person to check your blood pressure. Like I got my grandchildren, they tell your blood pressure, you got a sugar level, just to check your one. They feel good about it because they think that they're helping you. Okay, they're helping you. This is the human tendency to help other ones. It's very important. And we have to make them it's beneficial for other people. I don't know whether I answered your questions, but this is something make them interesting. I want to give a one comment before you go there. Previous question asked you what to be taught to teach, what area. I give a scenario. Suppose I come to your institute. Okay? I'm come to institute, I'm 18 years old or 20 years old. Then after that, I learned something. I learned something from getting a degree. I worked for 1 year to 2 years. Then suppose I'm a female, I got a child, and I have to take care of my child. And then I decided to not to work for 3 or 4 years, right? 3 or 4 years. And I decided not to work for 3 years. Now, what I need that if I want to go back to the university or the work so that I learn something or I can quickly learn something so that I can go back to my profession. You see what I mean? What it needs the ability for lifelong experience because there was a gap in like 5 or 6 years before my child, grown up, like becoming like 5 or 6 years, I cannot go there at work because of my family, or I have to take care of my parents or somebody else. I got a degree, I got skills. What I expect that it will be useful if the university give me some skills and abilities so that I can learn myself, and go back to my one. And that's very important. If you tell me that, this is the screwdriver you have, this is the way to use it. No, I want to know with this screwdriver what else I can do. What else I can do. How, it's not how I can do, what else I can do. The thinking ability develop, that is we need, because it's a real life, okay? Real life. Many people, they either a man or a woman, because of the family they have, they all love their children, love their family. They sometimes they have to take care of their parents, grandparents, or somebody. They cannot work all the time. They take it off for 1 year, 2 years, 3 years, 5 years, so that they can go back. That's very important to that. I'm watching you. I see that. Yeah. Thank you. Thank you. Yeah, I can. I'm watching it. I can see that. Thank you. Thank you. Thank you. Thank you. Thank you to all of you. Thank you. Thank you. Thank you.